Hey guys, so this is my newest piece, which I finished tonight. I'm pretty happy about it. I actually finished it 2 hours into my birthday, which is pretty fun. And in this video, I'm going to walk you through the math that I used, which is over here. Real quick before I walk you through it, I'll let you know that this will be available to purchase as prints in about 2 weeks. I'm getting it scanned this week. And that will be available online to use. You can use your coupon code if you'd like to purchase this, as with all other things. This is, the original is also available for sale. This is not one of the pieces that I have that have been pre-sold from the Kickstarter campaign. So if you're interested in purchasing the original, feel free to contact me. I have not, as of yet, decided what the price is going to be, but we can discuss that. This is 22 by 30 inches. It's on this really cool paper with these torn edges. The background is painted with watercolor using a sponge. The numbers, this is micron pen. I have black and blue, and the white is primarily colored pencil. The background for the ventricles, I used a white pen, which was actually difficult to find. I ended up using this guy, which is new for me. I ended up going through over $100 worth of tools just to do tests for the white and blue to make sure that this would work out well. And I'm happy with it, so it worked out. So it was worth it, I think. Okay, so the math in this piece is primarily meant to focus on the ventricles of the brain because I find them quite beautiful and fascinating. These are, think of them as sort of caverns inside your brain that are filled with cerebral spinal fluid that are produced from the choroid plexus. This supports the brain. It actually makes it quite a bit lighter. It nourishes the brain and it protects it from damage. It does a fairly good job of doing so. And it's drawn with information about its rate of production. It's produced, there's about 21 milliliters of cerebral spinal fluid produced in the ventricles every hour, about 600 every day. At any one time, there's about 100 to 160 milliliters, I believe. This is for a sort of normal averages. I also have the cerebral perfusion pressure equation in here, which is the mean arterial pressure. Subtract the intracranial pressure. Intracranial pressure is where you would have information about the cerebral spinal fluid involved. This is an equation that is important that would be used after traumatic brain injury. Changes in the cerebral perfusion pressure after traumatic brain injury can lead to the brain not getting enough blood flow, which would lead to neuronal death. And it's this sort of unpleasant cyclical experience where the pressure, I don't want to explain it poorly right now, but it's integrated properties of the pressure from the venous system and from the cerebral spinal fluid increasing while blood flow decreases, basically. And I just did a terrible job of explaining it, but this is important to see what's going to happen with the health of the cells in the brain after traumatic brain injury. I also have pressure for the cerebral spinal fluid in the ventricles when sitting up, which is the sort of average normals. And what else do I have? I think that's about it for there. The brain itself, I do have some of that same data involved, sort of surrounding this area and lining the outside of the brain here as well, which is not in blue, but it's there. And then the brain itself, I have primarily, let's see if we can clarify it for you to see. That is the Nernst equation or equilibrium potential. I learned a lot about that. I don't know if I spoke about it before, but there's extensive amounts of research on that and breaking down the equation and actually learning how to do it myself, which was challenging and fun. This is Ohm's law. I like having this in here because it shows sort of cross-scientific fields speaking for each other. This is definitely applicable for brain function, and it's not the only place where you would find for Ohm's law to speak well for a system, so I like this. I also have membrane potential and important neurotransmitters. For the excitatory neurotransmitter, I have glutamate, And for the inhibitory neurotransmitter, I have GABA, which are the two most important major neurotransmitters for the central nervous system. When we go into the peripheral nervous system, it goes to, and I don't know if I'm pronouncing this right, I don't know if it's glycine or glycine, and then acetylcholine. And I have a lot of glycine here near the spinal cord. I also have some molecules, and this is in this whole area here. I have serotonin, dopamine. I have quite a bit of ATP in the entire body. This is important for healthy cell firing just in general, and I can actually clarify this is ATP here, I believe. Is that what we got? Yeah, that's ATP right there. And as usual for my drawings, I also have hidden words. I'm gonna just do a nice little flyby here of the numbers. Well, I'm gonna try to do a nice flyby of the numbers. This will be easier to see once I do proper imaging of this. You guys can zoom in. Oh, there we go. That's the Nernst equation again. Oh, that's membrane potential. I have some millivolts in there, threshold millivolts for firing neurons. So I think that's all for me to explain. I'm excited for you guys to be able to see this in person. And if you have any questions, please send them to me. And this is the flyby of the math. This is most of the math. I may have some of it sitting elsewhere. This is most of the math and equations that I use throughout this. This is rate of production. There's Ohm's law. So pretty. All right. Well, I am so happy that I finished this on my birthday. I think that's a great day to finish this piece. I'm very happy with it. I hope you guys are as well. And I'm looking forward to drawing the next one. All right, take care, guys.